Hi guys, welcome back to Nunley Math. I'm Aaron Nunley. Thank you for joining me here today for the second video in our series of videos on how we use algebraic equations and expressions to model problems. You can see down here at the bottom of my slideshow I have links to the first video in the series. If you have not already watched that one, I would recommend watching it before continuing into this video because there are some important lessons that we talk about there. Specifically, we use the idea of magic to introduce how different number patterns can be represented algebraically. And then we solve some fun problems involving calendars. And then we look at consecutive integer, consecutive even, and consecutive odd problems. So check that one out. Also be sure to give us a big old thumbs up. For today, we're going to focus more specifically on geometry problems. And I've given you a geometry problem right here that's pretty standard. And it would appear in a lot of algebra and geometry textbooks. So let's take a look at what it says. Two angles are supplementary. One angle is 30 degrees more than twice the size of the other. What are their measures? Now, this problem is not terribly complex to solve if we understand what supplementary angles are. If we don't know what supplementary angles are, this becomes a very, very challenging problem, if not an impossible problem. So let me remind you of the definition of supplementary. Two angles are supplementary if the sum of their measures is 180 degrees. Or, as a picture, if you have a ray, that's an endpoint with an arrow going one direction, connected to another ray with the same endpoint going in the other direction, it forms a straight line. Because angles measure how far apart the space is between these two arrows. This right here, the distance across from here all the way around to here, is described as being divided into 180 equal segments that we refer to as degrees. 180 degrees. And in fact, all straight lines have 180 degrees if you're measuring the space from one side around to the other. Now, you can see that on the top side of this line, I've drawn another ray, that's an endpoint going up here, that has cut or split this 180 degree angle into two smaller angles. There's one up here, this is a large angle, an obtuse angle, and then you've got a small acute angle down here. And we know, since when we combine these two angles together, they have to total 180 degrees. We know these two have to add up to be 180. So if this was an 80 degree angle, this one must be a 100 degree angle because when you put them together, they make that straight line. If the smaller angle is 70, the bigger must be 110 because together they have to add up to be 180. If the smaller is 60, the larger has to be 120 because together they have to add up to be 180 degrees. So if I were to tell you that this angle is x degrees, the problem tells me that one angle is 30 degrees more than twice the size of the other. One angle is 30 more than twice the size of the other. If this is the measure of the smaller angle, we can describe this larger angle as being 30 more than twice the smaller. Do you know how we would write that algebraically? Well, hopefully you realize that is 30 more than twice the smaller angle. You see, this second sentence right here is the one that relates the small angle to the large angle. And the first sentence tells us that this smaller angle combined with this larger angle has to total 180 degrees. Therefore, if the first angle is x and the second angle is 2x plus 30, I can model this with the equation x plus 2x plus 30 equals 180 degrees. And I can solve this just like we did in our previous unit to figure out the measure of angle x. Again, I combine my like terms. I use the property of equality. And I come up with the fact that x is 50 degrees. Now notice I went through this fairly quickly because in my class we spend a lot of time solving these, and our focus now is not on the actual solving of the equation. This should almost be automatic at this point. The focus of this lesson is how to set the equation up. If solving the equation is problematic, you're going to want to go back and watch our lessons on solving algebraic equations. For us though, once we know that the first angle is 50 degrees, we know the second angle is going to be 2 times 50 plus 30 degrees, which is 130 degrees. The two angles are 50 and 1/3. Remember, the difficulty here is in remembering what supplementary is and then creating the algebraic model. Once we have the model created, the solving should be easy for you. In my class, I do require my students to define every variable so we know what it means. You can either define it the way we did here on the left, or you can define it using the picture that we have up here at the top. This would be considered the definition of those angles. Got the idea? I can do this same kind of a problem using complementary angles. Two angles are complementary. One angle is 3 times the size of the other. What are their measures? If you know what complementary is, this is fairly easy. If you don't know what complementary is, it becomes very difficult. The definition of complementary is two angles that add up to 90 degrees. And oftentimes we'll draw it looking like this. Notice that we have this large 90-degree angle right here. You can tell because I put that box in it. It turned out a little bit messy, but that's okay. We can get the idea. I've got this 90-degree angle, and then I draw another ray through the center that cuts this 90-degree angle into two smaller angles. The whole thing is 90, but it's split into two smaller angles. So if the smaller angle, or one of the angles, is 10, the other one might be 80 because that adds up to 90. Or if one of them is 20, the other might be 70 because that adds up to 90, or 30 and 60. If I know that one of the angles is unknown, or x, the problem tells me that one is 3 times the size of the other. If this one's x, how would I describe the other one? It's 3 times the other. Well, hopefully you can see that's going to be 3x. In fact, down here I would define the first angle as x and the second angle as 3x. And as long as I know that complementary means that these two have to add up to be 90, it's very easy to set up my equation. The first angle plus the second angle is 90. And we use a little bit of algebra to solve. Notice x comes out as 22.5. 3x should be 3 times as big, which is 77.5. And that's my set of angle measures. Again, being able to model this algebraically is a lot easier than having to just sit and guess and check numbers that add up to be 90 in order to come up with the right one. Got the idea? Let's look at some more geometry applications. The length of a rectangle measures 5 inches greater than the width. Write an equation to find the length and width if the perimeter is 58 inches. So notice I've got my picture of a rectangle here. I've got a length, a width, and a width. Remember, it doesn't matter which one is the length and which one is the width, but since it is a rectangle, the length on both sides is the same. The width on both sides is also the same. We also need to make sure we know the definition of perimeter. The perimeter of a figure is the distance around the outside of the figure, which means if I want to know the perimeter of this shape, I'm going to have to add together all 4 sides. That's the length plus the width plus the length plus the width. If you add all 4 of those together, that should give you the perimeter. Let's see what else we know. The length of the rectangle is 5 inches greater than the width. Remember in our previous video, I said that if you use multiple variables like this, it makes it a much, much harder problem. So what we want to do is we want to try and get rid of some of these variables. Notice the length is 5 inches greater than the width. Instead of using an L, I could describe this as a W plus 5. And the same thing on the bottom. Instead of using an L, I can replace it with a W plus 5. So that if the width is 2, the length would be 5 bigger, which is 7. If the width is 10, the length would be 5 bigger, which is, or 10 bigger, which is 15. Did I say that right? 5 bigger, which is 10 plus 5, which is 15. And I'm going to come down here to this pattern I created, and I'm going to plug in the things that I know. For example, I know the perimeter is 58 inches. That's given to me in the problem. I also know that instead of an L, I would like to use W plus 5 because we don't want to have more than one variable. I also have a W. My other length is W plus 5 plus my other W. Notice that I've got W, W, W. I've got 4 W's plus 10. 2, 3, 4 W's. And I have 5 and 5 make 10. And I can solve this using the property of equality and the property of equality. And I get that W is 12. In other words, if my width is 12, my length is 12 plus 5, which is 17, which means my width is 12 inches and my length is 17 inches. Here's one more type of problem I'd like us to look at. This is a triangle problem. It says a triangle has an angle that's double the size of the first angle and a third angle that is 20 degrees more than the first angle. Give the measure of each of the angles. So I'm going to define this with a picture. My first angle is always x. I'm told a triangle has an angle that is double the size of the first angle. What would that second angle be if it's double the first angle? Well, hopefully you realize that's 2x. And we have a third angle that is 20 degrees more than the first angle. 20 more than the first. How would you write that? Hopefully you realize it's x plus 20. There is one last thing you have to know about the angles in a triangle in order for this to work. If you know it, this is a pretty straightforward problem. If you don't know it, it is almost impossible. Do you know what that thing is? You have to realize that every triangle always has 180 degrees as the sum of its interior angles. In other words, no matter what triangle I give you, if I add up these inside angles, it will always make 180 degrees. If you know that, it's really easy to write your equation. One angle plus the second angle plus the third angle has to be 180. And from there, we just solve. Combine our x's, that's 4x's, plus the 20 that's left over. And then you just use the property of equality and the property of equality again, and you get x is 40 degrees. So if x is 40 degrees, what do you think 2x would be? Of course, that's 80 degrees, 2 times 40. And what about the third angle, the x plus 20? Well, that's 40 plus 20, which is 60 degrees. Those are the measures of your three angles. Also notice 40 plus 80 is 120 plus 60, which does add up to 180 degrees. I do have one more problem I want you to take a look at. In a particular isosceles triangle, the third angle is 60 degrees more than double the measure of the other two. Give the measure of each of the angles. Now, I always start by drawing myself a picture of a generic triangle. It just gives me a place where I can plug in my angles. Notice over here on the left, even though these are different sizes, I didn't need to draw that. I just needed some space to put my variables. So if you would like to pause the video and try plugging these in on your own, I would highly recommend that. If not, you can go ahead and watch me do it and we'll do it together. There is a vocabulary word in here. If you know this, it helps a great deal. If you don't know it, it's almost impossible to solve this problem. It says that this is an isosceles triangle. Do you know what isosceles triangles means? The definition of isosceles says that two of the sides are the same length and two of the angles are the same size. That's important because if I know that one of my angles is always x, the second angle would also be x because two of the angles are going to be the same size. Notice the last thing I'm told. The third angle is 60 degrees more than double the others. 60 more than double the others. Can you translate that? Well, hopefully you realize you have to double the others and then add 60. Once you know this, the hard part is really done because we already said every triangle has to add up to 180 degrees. So there's the first angle, the second angle, and the third angle for a total of 180. And there again, you should be able to solve this pretty quickly algebraically. That's 4x's and a 60 for the 180. 4x's is a 120, which means your x must be a 30-degree angle. Once you know that x is a 30-degree angle, you know the second angle is also x. It's 30 degrees as well. The third angle is going to be 2 times the 30, which is 60, plus 60, which is 120 degrees. There again, notice that the 120-degree angle, if I had known that in advance, I should have drawn as an obtuse angle, but I didn't need to know that in order to perform the calculations. Hopefully this has been useful for you. I tried to throw a variety of geometry problems that are pretty common. If you run into a geometry problem and it has a term in it you do not know, it's most of the time going to be extremely important for you to figure out what that term means before you attempt to solve the problem. So I'm going to highly recommend that you take the time to do that. As always, thank you so much for watching. I do wish you all the very, very best. Take care of yourselves. Make sure you give us a big old thumbs up. Make sure you subscribe or turn on your notifications so that you don't miss anything coming from us here at None in Math. As always, take care of yourselves, all right? Bye-bye.